The first section in Chapter 8 is titled Factors and Greatest Common Factors. Hopefully a lot of this lesson is a review for you. So we want to be able to write the prime factorization of numbers and also find the GCF, or the greatest common factor of monomials. So let's do some warm-up here. Let's first tell whether the second number is a factor of the first number. So is 8 a factor of 50? Remember, when a number is a factor of another number, it can be multiplied by something to equal that number. So is 8 times some other number 50? No, there's no number times 8 that's 50, so 8 is not a factor of 50. On number 2, we have 105 and 7. What we want to know is, essentially, does 7 divide evenly into 105? And it does. 7 times 15 is 105, so yes, 7 is a factor of 105. Number 3, I want you to list the factors of 28. Whenever you're asked to list factors, it's probably easiest to keep them in order, and you'll kind of see how I like to write it here. So the easiest factor of a number is 1 in itself. So I know that 1 times 28 is 28. I also know that 28 is even. So 2 times some number, and it happens to be 14, is 28. 28 is not divisible by 3, but it is divisible by 4. Whoops. 4 times 7 is 28. And it's not divisible by 5 or 6, and then that brings us back to 7, so that the factors of 28 are 1, 2, 4, 7, 14, and 28. I've got them spread out quite a bit there, but I like to write things in numerical order, keeping the pairs working their way inside. And you can write them however you'd like. Now let's review prime and composite. Remember, prime means it's only divisible by 1 in itself. Composite means it has other factors. So 11, hopefully you're saying, is prime. The only two numbers that multiply together to get 11 are 1 and 11. 98 we know is composite. It is even, so it's divisible by 2. That automatically gives us its second factors. And 103 maybe isn't one you know, but you might start dividing it by 2 or 3 on your calculator. Maybe check 4, 5, 6, and you will find that 103 is also prime. So let's talk about prime factorization. This is something hopefully that you did last year in pre-algebra, but prime factorization essentially is just a representation of a number or a polynomial as a product of primes, and it's typically done in a factor tree. So maybe you're familiar with the term factor tree, but we're going to do some factor trees now. So when you're asked to write the prime factorization of each number, you essentially want to start branching off of that number and coming up with different factors. What's nice about a factor tree is it doesn't matter which factors you start with, you should always end up at the same answer. So the most common factor I can think of for 60 is 6 and 10. Now, you might have started with 2 and 30. You could have started with 4 and 15. You will eventually get to the same answer. What you want to do with a factor tree is then continue to split the numbers as long as they are not prime. 6 is not prime. It splits down into 2 and 3. Now 2 and 3 are both prime, so we stop here. Now we move over to the 10. 10 is divisible by 2 and 5. Those numbers are now also both prime, so our factorization is stopped, and we need to write it out using exponents to indicate repeats. So what we have here is 2 times 2 times 3 times 5. What that means is if I multiply those four numbers together, I should get back to 60. But we want to make sure that we're writing any repeats using exponents. So we would say 2 squared, since there are 2 of them, times 3 times 5. Notice we also write our prime factors in numerical order. Let's try 98. 98's even, so I know it's divisible by 2. And it's 2 and 49. 2 is prime, so I can stop there, but 49 is divisible by 7 and 7. 7 is also prime, so I know that the prime factorization, or the factor tree, has stopped, and now I need to write it as a product of those prime factors. 2 times 7 squared. And notice it's 7 squared because there are 2 7s in our factor tree. If you multiply 2 times 7 times 7, you should get back to 98. Number 9 is 33. 33 breaks down to 3 and 11. Both of these numbers are prime, so the prime factorization for 33 is just 3 times 11. Pretty simple there. Try number 10 on your own. 40 isn't a humongously large number, but there are a lot of 2's involved. So we can split 40 into 2 and 20. We can split 20 into 2 and 10, and we can split 10 into 2 and 5. Notice I have 2, 2, 2, and 5, which we write as 2 cubed times 5. Again, if I multiply 2 times 2 times 2 times 5, I should get back to 40. 2 more examples. Try both of these on your own. 49 is 7 times 7, so that's just 7 squared. 19 is prime, so its prime factorization is just 19. Hopefully you got both of those right, but this is a lot of practice with factors and factor trees, which hopefully you've seen in the past. Now we want to talk about the greatest common factor. The greatest common factor is the greatest factor that's shared by 2 or more whole numbers. And to find the greatest common factor, we're going to find all of the factors of each number, and then the greatest of which is going to be the greatest common factor. So it's exactly what it sounds like. List the factors out for a series of numbers and find the largest one that they share. So we want to find the greatest common factor of 160. So the first thing I'm going to do is list the factors of 100. And once we get pretty good at this, we may not have to list them all out. But for 100, it's 1 and 100, 2 and 50, 4 and 25, 5 and 10. 100 is not divisible by 6, 7, 8, or 9. Then that brings us back to 10, so we know that we've found all the answers. Now let's look at the greatest common factor, or the factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, and 5 and 12. So you can see that even though a number may be smaller, it actually can have more factors. For example, 60 is a smaller number than 100, but it does have more factors. Well, now we want to find the greatest common factor. So you're simply finding the largest number that divides evenly into 160. So as we look down the list for 100, we have 100, 50, 25, and 10. Oh, and I think I missed one. 6 and 10. 60 is also divisible by 6 and 10. So there's your greatest common factors. We go down the list, 100, 50, 25. None of those are listed here. When we get to 10, we see that 10 is listed under both. So the greatest common factor of 160 is 10. And now as I'm looking at that, I realize it's not. I missed something here. What did I do? 1 and 100, 2 and 50, 4 and 25. Oh, 5 and 20. 5 times 20, and then the number 10. 10 times 10. So actually the greatest common factor, sorry about that, is larger than 10. It's actually 20. 20 divides evenly into both 160. And see, here I am trying to be super organized and still missed a factor. So let me make sure I have them again. 1 times 100, 2 times 50, 4 times 25, 5 times 20, and then 10 times 10. Whenever you have a multiple like 10 times 10, you only have to list that factor once. You don't have to list it twice. And then for 60, I think I got them all. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. 7, 8, 9. Yep. Okay. So the greatest common factor is 20. Phew. Okay, let's try a smaller one. Maybe smaller numbers will give me a little more success here. Find the greatest common factor of 26 and 52. And some of you are going to be able to look at these and know right away what's the biggest number that divides into both of them. 26 doesn't have a lot of factors. 1 and 26 and 2 and 13, and that's it. 52 is in a similar situation, but it's 1 and 52, 2 and 26, and 4 and 13. So now we find the largest number in both lists, and it's 26. So the greatest common factor for 26 and 52 is 26. It divides evenly into both of them, and it's the largest number that does that. Okay, I want you to go ahead and try this one on your own. So find the greatest common factor of 18 and 27. Now hopefully you're going to get to a place where you're going to be able to look at those numbers and know what divides into them or what their factors are, and then also know what the largest one is. So hopefully you're saying that the greatest common factor between 18 and 27 is 9. If we look at the factors of 18, they're 1 and 18, 2 and 9, and 3 and 6. Factors of 27 are 1 and 27, and 3 and 9. So you can see that 9 is the largest factor that's repeated in both of their lists, so it is the greatest common factor. The last thing we want to talk about quickly is the greatest common factor of monomials. So to find the greatest common factor of monomials, remember what a monomial is. It's a product of a number and or variables. So first you want to find the factors of the coefficients, just like we did, and then write all of the powers of each variable as products. So we're going to kind of string them all out. Then the product of the largest number and the smallest exponent in common with each monomial is the greatest common factor. And I know that that might seem a little confusing, so let's just look at some examples. Let's find the greatest common factor of 15x cubed and 9x squared. Well, let's ignore the variables for a second. Let's just talk about 15 and 9. What's the largest number that goes into both 15 and 9? Hopefully you're saying that's 3. Remember, the factors of 15 are 1 and 15 and 3 and 5. And the factors of 9 are 1 and 9 and 3 and 3. So the largest number that goes into both is 3. So our greatest common factor thus far is 3, but we have to take into account the exponents. So the 15x cubed is x times x times x. The x squared, 9x squared, is x times x. This is where it gets a little tricky. With the coefficients, we're looking for the largest number, so we took the 3. However, with the variables, you're looking for the smallest number in common. The most x's this term has to give are 2, so they can only share 2. So the greatest common factor is 3x squared. It can't be 3x cubed because the 9x squared doesn't have that third x to give or to share or have in common. Hopefully that makes sense. Let's look at a few more examples. 17, we have 8x squared and 7y cubed. So factors of 8 are 1 and 8, 2 and 4, and we have x times x. Factors of 7 are just 1 and 7, and we have y times y times y. So first we want to look at the numbers. We've got 1 and 7 and 1, 8, 2, 4. The largest number that they have in common, or the largest factor they have in common, is a 1. Now if we look at the variables, remember it's the largest number, or excuse me, the smallest number on the exponent, or the smallest amount that they both have in common. But the first term has x's. The second term has y's. That actually means that they don't have any variables in common, so none of the variables can be included in the greatest common factor. If the 8x squared doesn't have any y's in it, then y's can't be a factor of it. Similar with 7y cubed, if there are no x's there, then x's can't be a factor. So here the greatest common factor is just 1. Pause the video here and try this last one on your own. This one's a little more complicated. We have 27x squared y cubed, 45xy squared. So for 27, I'm going to list the factors 1 and 27, 3 and 9. 45 is a few more. 1 and 45, 3 and 15, 5 and 9. So you can see that the largest factor in common is the 9. But now let's talk about the variables. We have x times x and y times y times y on the left, and we have x, y times y on the right. So the greatest common factor is, again, the largest number that they have in common. That's the 9. But the fewest of the variables they share. So they do share x's. I have 2 on the left and 1 on the right. So we're going to take the 1 from the right because that's all this one can share. And for the y's, we have a y cubed and a y squared. Again, we're going to take the 2 from the right because that's all that term can share. This term can't share 3 y's, it only has 2. So hopefully that makes sense. It's the largest factor on the coefficients, but it's the smallest number of the variables that they have in common. Remember, they have to have them in common. If they don't have them in common, like the last example, then they can't share any, or none can be included in the factor. So do you remember the prime factorization of numbers and writing factor trees? And can you find the greatest common factors of monomials? Those were those last 3 examples. We'll go over questions in class, and we will work on worksheet 8.1.